So we are doing number 65. What distribution do you think we are using here? What distribution are we using? Is it a uniform distribution? Is it a binomial distribution? Is it a geometric distribution? Is it a negative geometric distribution? Those are the distributions we have learned about. In a uniform distribution, the probability for any outcome is the same. That's why we call it uniform. In a binomial distribution, you have a fixed number of trials. You want to check if the trials are independent of each other. You want to check if the probability of success at each trial remains the same. Here, do we have a fixed number of trials? What is that number of trials? What is a trial here? We want to identify, is this something that may occur or not? The trial has two outcomes. What trial here do you think have two outcomes? Whether there is a hurricane or not, because there is at most one. Is there a hurricane or is there not a hurricane? So are those trials independent of each other every year? They are independent. Are we expected to have, do we have a fixed number of trials here? So here we can identify that success, what is success here? Hurricane. And what is the probability of success? 0.05. What is the number of trials here? Pardon? What? So, to have a binomial distribution, you need N and P. If you have N and P, this is the notation for a binomial distribution. Here, N equals to 20, and P equals to 0.05. What is the probability we want to find? The probability that I can't hear you. Fewer than 3, that is x is less than 3. You can use your calculator. You can use the binomial distribution formula. P of x equals to ncx ex qn minus x. This will take a longer time. Here you will have p of 0 equals to 20 c0. You don't really need to write this. P of 0 will be 0.95 raised to the power 20. P of 1 will be 20p q 19. P of 2 will be 20 combination 2. Our p here is 0.05. And our q here is 0.9. Now, this will help us to get P of 0, P of 1, P of 2. And we will add them to get the probability that we have fewer than 3. Does that make sense? Any question? You can use your TI-83 calculator to do this for this class, but if you are taking an actual exam, they will not accept that calculator. So you will need to take, there are some simple calculator that can give you the combinations. A calculator that is acceptable can do combination and permutation. That's why I'm asking you to do these problems, those homework problems, because that will help you to know if you are understanding what you are doing. I don't want to force you to do all those problems. That's why I select some. If you do one and you don't understand, we bring it to class and we will discuss it. So you can do this one, right? Can you complete it? Can you complete this? Binomial distribution calculator. No, exam will not allow you to use this one. I'm just using it because I want to check. Probability of success, 0.05. Number of trials, 20. Number of success, 3. And it will give me all sort of answers of questions about 3. So what we are interested on is x is less than 3, which is 0.92. So let's look at number 66 if we are done with this. If you are using a TI-83 to do this, then what we are asking you is less than or equals to 2, and you can use the cumulative distribution, binomial CDF. If you are using the TI-83, you can use, instead of less than 3, you use less than or equals to 2 to use CDF. In my statistics class, they have a lot of trouble to understand that, but you want to know that if you are looking for numbers, natural numbers that are less than 3, these are numbers that are less than or equals to 2. CDF includes the value that you have. Let's take 2 or 3 minutes to look at number 66 before we teach Poisson distribution. Actually, we need to mention hypergeometric distribution. Any idea, any solution? Anyone has a way to do it? So what do we have as information? N equals to 10, the variance of x equals to 0.25 times the expectation of x. So n equals to 10. Variance of x is equals to 1 over 4 e of x. Remember that e of x is equals to np. And the variance of x, what is the variance of x for a binomial distribution? NPQ. So this formula tells us that NPQ is equals to NP over 4. So what can we say? Q equals to 1/4. So can you find P? Okay. Okay. Wasn't generally use the information that you have. You will get to the. Okay. So I think you can complete this now that you know N and P. Find the probability of success, find the probability of x equals to 7, we can leave that. Practice more problems here. Let's look at this 72. I'm going to do 72. Let's be a geometric distribution. And we want to show that the probability that x is greater than a plus b, given that x is greater than a, is the same as the probability that x is greater than b. For example, we are saying here that you have made at least, you have already made more than 3 successes. You have already succeeded more than 3 times. What is the probability that you will succeed more than 5 times? It is just the probability that you will succeed again more than 2 times. Does it make some sense in the understanding of the meaning of the problem? So given that the number of success is more than A, what is the probability that the number of success is more than A plus B? In other words, simply put, given that the number of success is more than 3, let's say that success is you have passed your exam. So 10 people are randomly selected, not 10 people, anyway, in a population in general, we don't fix it. In a population, you know that more than 3 people, let's say, have a disease. What is the probability that there will be more than 10 people that have the disease. Instead of finding the probability there will be more than 10 people, given that there are more than 3, it is just the same as there are more than seven more people to have the disease. So that is called the memoryless property of the geometric distribution. Let X be a geometric distribution. Show that the probability that X is greater than A plus B, or B plus A, okay, A plus B, given that A is greater than, given that X is greater than A is the same as the probability that X is greater than. It makes sense naturally. This is it here. So we know that the probability that X is greater than A plus B, given that X is greater than A, we use the definition, is the probability that X is greater than A plus B and X is greater than A. So intersection X is greater than A. Can we just leave it X is greater than A plus B? We want A intersection B. A is X is greater than A plus B. B is X is greater than A. And we say that if X is greater than 3 and X is greater than 10, that just means X is greater than 10. Let's say this is A and this is B. A plus B could be somewhere here. So X greater than A, we start from here. X greater than A plus B. This property is true when A and B are positive numbers. So the intersection is X is greater than A plus B divided by probability that X is greater than A. Now, the probability that what is the probability that X is greater than A? It's equal to 1 minus probability that X is less than or equals to A. Is this correct? The probability that X is greater than A is 1 minus the probability that X is less than or equals to A. Now we want to find probability that X is less than or equals to A. It is equal to the sum from 1 let's say 0. This is a geometric distribution. It starts from 0 to A. P of X, which is the sum from 0 to A. Remember the geometric distribution, P times Q raised to power X. Remember that in the geometric distribution, we have X is the number of failure before the first success. You could remember the probability distribution of a geometric distribution. Is that right? Which is equal to P, sum of 0 to A, QX. Can somebody tell me what will be this sum? Sum from 0 to A of Q of X. I want you to get used to those expressions. Remember that it is 1 plus X plus X raised to power K. If I call this one S, then AS will be x times s will be s x plus x squared plus x a plus 1. If we start from 1, so what I mean by starting from 1, when 0 equals to 1, then we will be starting from x. So now, when I do s minus xs, I get 1 minus xa plus 1. So s, this sum will be 1 minus xa plus 1. So we are going to write this as p times y minus q a plus 1 divided by 1 minus q, which is 1 minus q a plus 1. This doesn't make sense to you? Remember, we are interested in p of x greater than a. So p of x greater than a, we say is 1 minus p of x less than or equals to, which is 1 minus q a plus 1, which is equal to what? What will be 1 minus q a plus 1? It should be q a plus 1. I'm sorry, this is a. And what is p of x greater than a plus b? What do you think will be p of x greater than a plus b? X greater than a plus b? Look at p of x greater than a. Jacob, say something. This is greater than a, x greater than a. What will be p of x greater than b? Greater than. This is greater than a. P of x greater than a. So a can be anything, right? And we say a can be anything. Okay. So what is p of x greater than a plus b? P of a plus b, because we choose a, it was just a letter. We can do anything, we can say it is k. We can say it is anything. It becomes a function. Okay? We don't want to show that it's a function. You know, you can see it's a function. Do you know how to check if it is a function or not? Jacob should check if it is a function. Listen, did you do discrete math? Computer science? We said that it's a function is that f of k If you take any variable, f of a is unique. So if f of a equals to b, and f of a equals to c, then b equals to c. Naturally, it is a function. Okay. Is it a one-to-one function? Is it one-to-one? We can divert here a little bit. It will be one-to-one if f of a equals to f of b, imply a equals to b. F of a is q, a plus 1. F of b is q, a plus 1. Does it imply a equals to b? It's a function. We call it probability distribution function. So it is a function. And it is even a one-to-one function. Anyway, that was just to play around a little. So that you should get used to the fact that when we are dealing with a function, it could be expressed in a way you are not used to. A probability is a function. So I'm going to erase this. This is homework you would have been doing. I realize that we are moving, but I'm not sure if you can solve problems. That's why I felt today, let's do some problems. Remember that we say probability that x is greater than a plus b, given that x is greater than a, is equal to probability that x is greater than a plus b, divided by probability that x is greater than a. This is what we want to show. Can you complete it? I will say here that you can complete this one. So I want to add one thing for the remaining 2 minutes that we have. I don't want to come back to hypergeometric distribution. A box contains B blue balls, B blue balls, and G green balls. N balls are randomly selected. We have done this type of problem before. Do you remember that? N balls are randomly selected. X equals to the number of blue balls is a hypergeometric distribution. That is it for hypergeometric distribution. It's a distribution like that. The difference here is that they are not actually independent when you select the balls because you are not returning them. When you select the ball, so we will have here that P of x equals to k. That is the probability that you have k blue balls will be equals to choosing k blue balls out of k, and then n minus k balls out of the green, divided by blue plus b plus g, if you can understand what I mean here, combination n, the total number of balls. So if n equals to b plus g, then P of x equals to k is b combination k times g combination n minus k divided by n combination. This is what is called a geometric distribution. On Wednesday, we are going to do Poisson distribution. When we do problems, it slows us down. But when we do problems, you understand better. So most likely your take-home problem, you will have to submit it on Monday because I was thinking we finished today. What is left is the Poisson distribution. But we have not completed it because I prefer that we do some problems on the binomial and the geometric distribution.